talking about simplifying here. You're simply talking about factoring the top, which is x minus 7, x plus 5, over x plus, x minus 7, x minus 2. Okay. Now, on the final, they don't really talk much about what can't equal 0. We actually make it kind of simple for you. That cancels, and your answer is x plus 5 over x minus 2. And that's it. Right, it's really not as in-depth as it quite possibly could be. Here, when you're multiplying fractions, we're factoring all 4 spots. I take a 6 out, I'm left with x minus 3. X squared minus 64 is x minus 8, x plus 8. Since it's multiplication, we just keep the fraction in the same order. X minus 8, x plus 6, over x plus 2, x minus 3. And we're looking to cancel diagonally. The x minus 3 is canceled. The x minus 8 is canceled. And I'm left with 6 times x plus 6 over x plus 8 times x plus 2. Right? We cancel vertically, we cancel diagonally, we multiply across horizontally. We multiply horizontally, you don't cancel horizontally. With division, the first thing I would do is rewrite the first fraction and flip the second. Don't do any factor. Don't do anything to it. Okay? Not rewriting is lazy. There's no other way around it. It's lazy. Here, I can take a 7 out. X minus 4. Oops. That was a meter. Over 14x times x minus 4, x plus 4. Okay, we've got to be able to factor. The x minus 4 is canceled. The x is canceled. And 7 over 14 reduces to 1 over 2. So up top, everything's gone, so we're left with a 1. On the bottom, we're left with a 2 times x plus 4. And you read the multiple choice, whether it's 1 over 2x plus 8 or 1 over 2 times x plus 4. The multiple choice will dictate that. This is a gift. They give you a hidden fraction problem with a common denominator. You don't even need to get the common denominator. You just write it down. 12 and 21 is 33, and that reduces to 3 over x. Don't overcomplicate here. I've had a few questions. What do I do here? See how they give you p of negative 5? You plug that in for your x. Your answer is 13. That's it. That's it. See how r is 2a? You plug that in for x. 2a cubed minus 5 times 2a plus 7. 2a cubed is 8a cubed. 5 times, or negative 5 times 2a is negative 10a plus 7. That's it. The next one, this is studying. The leading coefficient is 3. The degree is 6. The degree of a question is always the highest exponent. And the leading coefficient is always the coefficient of the variable with the highest exponent. Okay. What is the maximum and minimum value of the graph below? What you're looking for is, what is the local maximum and local minimum? Okay. So the extreme max would be negative infinity to infinity. Okay, that's the extreme min. Extreme max is infinity. Okay, the extreme min is X. They were looking for that point, it would be this. Okay. What they're really looking for here is a local max and a local min. Now, on the test, they'll ask for a point. Local maxes and local mins really refer to the y's. Okay, but they'll probably ask where at a point is your local maximum and local minimum. So what I would suggest doing is this. Okay. On this graph, I'm going to kind of guess the point. The local minimum, where there's a bounce, is really negative 1/2 and 0. And I would say the local max, to me, looks like 3/2, 3/2. The point on the test, draw a graph with ending behavior. Okay. And what we need to remember about ending behavior is this. When these follow each other, okay, in this fashion, that means we have even degree. Okay? So when it doesn't matter whether x is approaching infinity or negative infinity, which means as I'm going this way or as I'm going this way, my y is going to the same spot, that means we have even degree. Okay? The fact that the infinities are positive means just the fact that these infinities are positive means that's what my graph is going to look like. Okay? Really what you're looking for, you don't even have to worry about this. Now, I did this correctly. Okay? The other really option you could have here, okay, would be something like this. Either option would work because can we agree on both these graphs? As x goes to infinity, y goes to infinity. Can we agree as x goes to negative infinity, y goes to infinity? Can we agree the same deal here? As x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. Oh, I'm sorry. As x goes to negative infinity, y also goes to infinity. Okay, essentially, we need even degree. This represents an x to the fourth. There's 3 bounces. This represents x squared. There's 1 bounce. That's probably the one you're a little more familiar with. Okay? But ultimately, okay, either one of these graphs could be an answer. All right, my math exam. I've already drawn my lines here. We have 85, which means a distribution, a standard deviation of 3, 88, 91, 94, 82, 79, 76. Okay, so that's the presentation with a mean of 85 and a standard deviation of 3. What is the percentage score between 82 and 91? Well, 34 and 34, 13.5 and 13.5, 2.35 and 2.35, 0.15 and 0.15. Between 82 and 91, 82 to 91, that's 81.5%. Between 76 and 94, 99.7%. Greater than 88. We're just dealing with this, 2.5 and 13.5. There's a 16% chance we are greater than 88. And what is the chance lower than 79? 2.5. We're just reading off of that normal curve. Write an example of an equation with exponential growth. Write an example of an equation with exponential decay. Growth, decay. The initial amount is irrelevant. Okay, I can put any number I want. I'll put 1,000 in for both. We know they're always going to equal y. That doesn't change anything. The difference between growth and decay is also not the exponent. Let's say I want to do something over 4 years. It's the same look for growth or decay. But it might, let's use 1% so we're consistent. Let's say I had 3% growth compared to 3% decay. Here's the big difference. When it's growth, it's always bigger than 1. And when it's decay, it's less than 1. All those numbers are made up there. Okay? But I know if I have growth, it's going to be 1 point something. And if I have decay, it's going to be 0.9. Not 0.9, but point something. It's going to be less than 1. So now to execute how to do this problem, we have a population in South Brunswick that's 50,000. And it's decreasing at a rate of 9% each year. How many people live in South Brunswick in X years? It's simply this. 50,000 times 0.91 raised to the X. And on the test, they're not going to actually ask you for the amount of years. They just want you to give the equation. That's it. It was brought to my attention. I skipped the question. I apologize. I never scrolled it all the way down. How many zeros are on this graph? It couldn't be simpler. 1, 2, 3, 4. Wherever you cross the x-axis, that's your